Right, this is a video of factoring and using the quadratic formula that does most activity. So some of these slides are just notes. So there are different methods to solve a quadratic equation. You can solve by using the following methods. So you can use the square root if there's no x term, or if the equation looks like something in parentheses squared equals a number. And then you can take the square root of both sides. Or you can solve by completing the square. Next week we'll learn about that. Today we're going to learn about factoring. You could also graph the quadratic itself and find the x-intercepts on a calculator. And today we'll also try to use the quadratic formula to solve a quadratic. So today, once again, we'll be solving quadratics by factoring and using the quadratic formula. If we don't get to this using the quadratic formula, we'll do it the next class. Whoops. Hit the wrong button there. So the next button, so when we solve a quadratic by factoring, we're going to use the zero product property that says if a times b equals 0, then a equals 0 and or b equals 0. So when we factor, sometimes we have to look for special cases. So the first special case you should always check for to see if there's a greatest common factor, and you're going to divide that out and then factor that way. So here's an example: x squared minus 8x equals 0. So common to both of these terms is an x. So I factor out that x, and then x times x minus 8. So in other words, I'm doing x squared divided by x, I get x, and 8x divided by x is 8, and then this minus sign in between. So now we have two factors multiplied together equals 0, so the one or the other has to equal 0. So x equals 0 or x minus 8 equals 0. And then solve both of these. This is solved already. X equals 0. And then add 8 to both sides and you get x equal 8. The next special case you're going to look for is the difference of two squares. So you find the square root of each term. Square root of a squared is a, square root of b squared is b, and then you put a plus and a minus in between those two terms. So if I have 25x squared minus 49 equals 0, then the square root of 25x squared is 5x, and the square root of 49 is 7. And then I put a plus and minus in between there. In other words, if I multiply this back together, I should get what I originally started with. So when you're factoring, that's one way you can check to see if you factored properly, is multiply the factors back together, and you should get what you originally started with. So 5x times 5x is 25x squared, and then 5x times 7, that's 35x, but then I have minus 35x, that adds up to 0. And then negative 7 times positive 7 is negative 49. So if I multiply this back together, I do get this here. So I equate each factor to 0 and then solve for x. So the first one, 5x minus 7 equals 0, add 7, and then divide by 5, I get 7/5. In the second equation, 5x plus 7 equals 0, subtract 7 from both sides, and then divide by 5, I get negative 7/5. So every quadratic has two answers, or it's going to have a repeated answer. And later on, we'll talk about imaginary answer. So it could have no real solution, a quadratic, but eventually we're going to find out about imaginary solutions or complex solutions. So the third thing is, if I have this x squared plus bx plus c equals 0, it should say ax squared plus bx plus c equals 0 and a equal 1, then you're going to find two numbers whose product is c and sum is b. So whatever this number is, you're going to find the factors of it, and then you're going to add them together to get b. So here's an example. X squared plus 5x plus 6 equals 0. So I'm looking for the factors of 6 that give me a 5. So the only factors of 6 are 6 and 1 and 3 and 2. 6 and 1, if I add those together, it gives me a 7. But 3 and 2 added together give me 5. So this factors into x plus 3 and x plus 2. And then equate each factor to 0, and I get x equal negative 3 or x equal negative 2. And then the bottom example here, I want the factors of negative 56 that when I add them together I get a negative 1. That's negative 8 and 7. So the factors will be x minus 8 and x plus 7 equals 0. And equate each factor to 0, and I solve. I get x equal 8 or x equal negative 7. And then for each of these, you want to solve them. So here, you're looking for the factors of negative 15 that when you add them together, you get a 2. So the only factors of 15 are 15 and 1 and 5 and 3. So in order to get a positive 2, then the 5 has to be positive and the 3 has to be negative. So this factors into x minus 3 and x plus 5. Let me make this bigger so you can see it. So then equate each factor to 0. X minus 3 equals 0, or x, whoops, there should be a plus here, or x plus 5 equals 0. And then if I solve each of those equations there, x equal 3 or x equal negative 5. This next one has a common factor. So you're going to do x times x minus 3 equals 0. So x equals 0 or x minus 3 equals 0. X equals 0 or x equal 3. In the last one, first I'm going to subtract. I'm going to get all the terms on one side. So if all the terms are not on one side, then you have to get them on one side. So I'm going to subtract 5x from both sides first. So I have an equation that a quadratic that equals 0. And then common factor is x again. So x equals 0 or x minus 5 equals 0. X equals 0 or x equal 5. All right, slide 4 is a note slide again. So when the coefficient is not, when this a value is not 1, then there's a different way we're going to factor. So if I have a squared plus bx plus c equals 0 and a is not equal 1, factoring a trinomial when the coefficient is not, the leading coefficient is not 1, here's the step. So here we're going to try to solve this equation, 6x squared plus x minus 2 equals 0. So what we're going to do first is multiply the a and c value together. So multiply the leading coefficient, which is 6, and the constant term, which is negative 2. So here it says the first and last numbers together. So 6 and negative 2, you multiply those together, you get negative 12. Then you want to list all the factors of negative 12. So negative 12 and 1, 12 and negative 1, negative 6 and 2. So one or the other has to be negative here. 6 and negative 2, 4 and negative 3. But looking back up at the original, we want those to add up to 1 here. So that's 4 plus negative 3. So after we find these two factors, we're going to split this 1x into 4x and minus 3x. So if I add these together, 4x and negative 3x, I do get 1x. So I split the 1x into 4x minus 3x. And then I'm going to group these two terms together, 6x squared plus 4x, and what's common to those two is 2x. And the only thing that's common to these two, 3x and negative 2, is a negative. So I factor that out, that negative out. So factoring out a 2x in the first group, I get 3x plus 2, and then factoring out a negative in the second grouping there, I get 3x plus 2. And then the reverse of the distributive property here, so 2x, this is actually a 1 in front of here, so 2x minus 1 times 3x plus 2, and then solve each of these two equations here. I get x equal 1/2 or x equal negative 2/3. So here's the same algorithm, a modified version of that algorithm. The first two steps are the same. I'm still going to multiply a and c together, and then I'm going to find the factors in negative 12 that add up to 1, which are 4 and negative 3. But then the next step I can do is just take these two numbers, 4 and negative 3, and then divide by the leading coefficient, the a value. So 4/6 and negative 3/6, and then simplify those two fractions. So 4/6 simplifies to 2/3, and negative 3/6 simplifies to negative 1/2. And then the denominator is going to be the coefficient of x, and the numerator is going to be the constant term. So the first fraction, 2/3, becomes 3x plus 2, and the second fraction, negative 1/2, becomes 2x minus 1. Always put the negative with the constant term or number there. So then I end up with the same factorization as the previous slide, and then solve each one of those. The solutions are actually going to be the opposites of these two numbers. So the opposite of 2/3 is negative 2/3, and the opposite of negative 1/2 is positive 1/2. So that's sort of I don't have to go through all that factor by grouping stuff. This is an algorithm that will always work. So I don't have to use factor by grouping, which is something we haven't taught you yet anyway. So you can just use the algorithm. So here's factoring when the leading coefficient is not equal to 1. So what you do first in the algorithm is do 6 times negative 5 and that's equal to negative 30. And I want to find the factors of negative 30 that when I add them together, I get a negative 7. So that would be negative 10. So let me write that as a sentence. So be negative 10 and 3. So next, I want to take those two numbers and divide by 6. So negative 10 divided by 6, and 3 divided by 6. Simplify those two fractions. Would be negative 5/3. And 1/2. I want to turn these into factorization. What did I just do here? Got to start over here. Got distracted by some keyboard stroke there. So once again, you want to multiply 6 times negative 5. That's negative 30. So the factors of the negative 30 that add to negative 7 are negative 10 and 3. I'm going to take those two numbers and divide by negative 6. So negative 10 divided by 6. And 3 divided by 6. Simplify those two factors, or those two fractions. Becomes negative 5/3 and 1/6. Or 1/2, sorry. Then I want to change these two things into factors. So that becomes 3x minus 5. So this 3 goes in front of the x, the negative 5 becomes my constant term, and 2x plus 1. So you equate those to 0. 3x minus 5 equals 0, or 3x minus 5 times 2x plus 1 equals 0. Equate each factor to 0. 3x minus 5 equals 0, or 2x plus 1 equals 0. X equal 5. When I add 5 to both sides, over here, when I subtract 1 from both sides, 2x equal negative 1. And then the last step, there's divide by 3 here on the left. So x is 5/3, or x equal negative 1/2. Or you could just take the opposite of these two things here. 5/3, negative 5/3. The opposite would be positive 5/3. Opposite of 1/2 is negative 1/2. So if you multiplied this back together, you would end up with 6x squared minus 7x minus 5. So number 2 here, we want to multiply 3 times negative 4. And that's equal to negative 12. And then the factors of negative 12, that sum to negative 1 are 4 and negative 3, or negative 4 and 3. Negative 4 and positive 3. And then you want to take both of these factors and divide by 3. So negative 4/3 and 3/3. Simplified, that becomes negative 4/3 stays the same. And 1/1. So then it becomes a factored form. It becomes 3a minus 4 takes care of this fraction, simplified, and then a plus 1 equals 0. And 3a minus 4 equals 0, or a plus 1 equals 0. Solving each of those. Add 4 and divide by 3. A equal 4/3. Or a equal -1. So the opposite of -4/3, positive 4/3, opposite of 1 is -1. The third one there, I'm going to start by multiplying 6 times -7, -42. The factors, so there's a 1 in front of -1 in front of the b, so you want the factors of 42 that sum to -1 are -7 and 6. I'm going to take each of those numbers and divide by 6, and then simplify if you can. So it's -7/6. And 6/6. I can't simplify the first one any further, so you can leave it at -7/6. And 6/6 becomes 1/1. So the factored form, the first fraction becomes 6x minus 7. The second fraction becomes x plus 1 equals 0. So 6x minus 7 equals 0, or x plus 1 equals 0. I get 7/6 or -1. And notice that's the opposite of these two fractions right here. This one's going to be a little bit harder because you get a larger number when you multiply these together here. So 5 times -21 equals -105. Now you want to find the factors of negative 105 that give you a negative 32. So let me think here a minute. So if I divide 105 by 5, I get 21. .35 times 3 is 105. So, and that will give me a 32. So negative 35 and positive 3 work. Then you want to divide each of those by 5. Negative 35 divided by 5. And 3 divided by 5. So the first fraction becomes negative 7 over, or 7 over, let me say that again. Well, first of all, let me simplify these. So negative 35 over 5 becomes negative 7 over 1. And 3/5 doesn't simplify. So the factor form is going to be x minus 7 times, well, it's n, so let me use that. So n minus 7 and 5n plus 3 equals 0. And I should have used b here, just to be consistent. Let me make these b's here. Let me make sure I did all the variables correct here. Should be a b. Second one is a. First one's x. No, I got them all with the right variable. So n minus 7 equals 0, or 5n plus 3 equals 0. So the two answers, I get n equals 7 or n equal 3/5. Notice that those are just the opposite of these two numbers here. So opposite of negative 7, positive 7. Opposite of 3/5 is negative 3/5. So here's extra practice when the leading coefficient is 1. In other words, the a value is 1 here. So all you have to do is find the factors of 35 that add to 12. 7 and 5. Get r plus 7 and r plus 5. R plus 7 equals 0, or r plus 5 equals 0. Solve both of those equations. R equal -7, or r equal -5. The second one, you want to find the factors of -21. Should have an S on it. Of -21. That add to -4 are -7 and +3. So the factorization becomes m minus 7 and m plus 3 equals 0. Solving those two equations there. M equals 7 or m equal -3. This is a special case here. It has a common factor of x, so factor out at x. X equals 0 or x minus 8 equals 0. Solve both of those. The first one's already solved. X equals 0. And the second equation there, x equals 8. And then this last one here, you're going to add 4 to both sides to get everything on one side equal to 0. So x squared, let me get the equation editor here. X squared plus 6x Add 4 minus 7 equals 0. And factors of -7 that sum to +6. Or 7 and -1. The factorization becomes x plus 7 and x minus 1 equals 0. Equate each factor to 0. X equal -7. X equal 1. All right, so you can derive the quadratic formula by completing the square. I'm not going to go through all the steps. You can look at these on your own. But you end up with this quadratic equation here. X equal -b plus or minus square root of b squared minus 4ac over 2a. So the rest of the problems on slide 9, 10, and 11, you're just going to use the quadratic formula to find the answer. So when you use the quadratic formula, it's just going to pick off the a value. In this case is 2. There we go. The b value is -5. And the c value in this first example is -10. And then plugging into the quadratic formula. X equal the opposite of b is 5. So there's a way to get a plus or minus here. So on Windows, it's Alt plus 0177 on the keyboard. And then the Macintosh, looks like Options plus Shift plus equal on the non-numeric keypad. Let me try Alt plus 241 here. Oh, hit the Alt key and then 241. So Alt 241 gives you the plus or minus symbol on Windows. and then square roots. So I have to use a keyboard for that. And then -5 squared is 25. I'm just going to type that in instead of putting parentheses around the -5 and squaring it. Well, maybe I'll do it just to emphasize that it's actually this. So make sure you're doing this on the calculator. Is -5 in parentheses squared. And then -4 times 2 times 10. And I need to put parentheses around this whole thing because you're dividing by 2 times a. And then you can take the parentheses away to kind of make this look better. All right. So now you have to simplify some things here. 5, and then Alt 241 on the keypad. And then when you let go of the Alt key, gives the plus minus symbol. 25 minus 80. Well, this is a negative. Otherwise, we'd get no real solution there. So that becomes plus. And then divided by 4. And then simplify under the radical here. We're not going to simplify any radicals. You can just leave the number like it is. You used to simplify radicals, but not anymore. 5, Alt, 241. And then square root 104. 105. Divided by 4. Just leave the answer like this instead of get the decimal approximation. You just leave it like that. And then the second one here, 3, 10, and 6. So the b value, 10. So the opposite of 10 is negative 10. Keep hitting the wrong digits. The plus minus, it's 241. So alt 241 square root. So I'm just going to do 10 squared, which is 100, and minus 4 times 3 times 6. And divided by 2 times 3, which is 6. So this is going to be 100 minus 12 times 6 is 72. 100 minus 72 would be 28. You can take away these parentheses if you like after you get the right fraction there. All right, this one you'd have to subtract 6 from both sides. So A is 5, B is 3, C is negative 6. And I'm just going to start with the parentheses so I don't have to put them in later. So negative 3, opposite of B, negative 3, alt 241, square root. And I'm just going to square the B, which is 9. 3 squared would be 9. Minus 4 times 5 times negative 6. And then divided by 2a would be 2 times 5, or 10. And then simplify what's under the radical. X, whoop, and get the equation x. X equal negative 3, alt 241, square root. So this would be 20 times 6 is 120 plus 9 would be 129 under the radical divided by 10. And you can always take these parentheses away after you're done to make it look a little neater. This next one, we'd have to subtract 3 first. A is 2, B is 9, C is negative 3. Plugging into the quadratic formula. So the opposite of B would be negative 9. And then square root B squared is 81 minus 4 times 2 times negative 3. And then divided by 2 times A, which is 4. Next, you want to simplify what's under the radical x. So 8 times 3 is 24. This can become positive because there's 2 negatives here. Multiply together makes a positive. 81 and 24 is 105. Just take away the parentheses there. All right, then the last slide. A is negative 5. B is 4. C is 2. The opposite of B would be negative 4. Oop. Keep getting the wrong number here. So 241. Getting all combinations of 2, 4, and 1 is 241. You get the plus or minus. So Alt 241. On Windows. And then square root. B squared is 16 minus 4 times negative 5 times 2. And divided by 2 times negative 5 is negative 10. Can't see what I'm doing here. Negative 10 in the denominator. And x before and square root. If I multiply these together, I get 40 plus 16 is 56. You could change the signs here. This was fine. You could change this to plus 4 and this is plus 10. When I divide a negative by a negative, I get positive. So I'm going to go ahead and take those away. And this last one here, you're going to subtract 5 from both sides. So a is negative 2, b is 8, and c is negative 5. So plug it into the quadratic. The opposite of 8 is negative 8. And square root 8 squared will be 64. 4 times negative 2 times negative 5. And divided by 2 times a is negative 4. And then simplifying what's under the radical there. This becomes 8 times 5, and it's going to be negative 40. So 64 minus 40 is 24. Oh, let's just take the negatives off here in the parentheses. Whoop. All right, so that's solving by factoring and the quadratic formula. We're not going to get through all these tomorrow, so we'll probably do just the factoring tomorrow and then the quadratic formula next time we meet.